Aggregates consist of one or more entities and value objects that change together. We need to treat them as a unit for data changes, and we need to consider the entire aggregate's consistency before we apply changes. In the examples shown here, the address is part of the customer, and the component is quite literally a part of the product. We can treat a set of changes to a customer and their address as a single transaction. Every aggregate must have an aggregate root, which is the parent object of all members of the aggregate. And it's possible to have an aggregate that consists of just one object, in which case that object would still be the aggregate root.
In some cases, the aggregate may have rules that enforce data consistency that apply across multiple objects. For instance, maybe our product consists of a collection of components, but in order to be in a valid state, it needs to have a specific set of such components. As an example, if the product is a Lego minifig, the collection of parts won't be a valid product unless it includes a head, an upper torso, a lower torso, 2 arms, 2 hands, and 2 legs. If we allowed the collection of components to be modified independently of the product it was associated with, we could easily end up with consistency problems. If we want to modify the composition of a product in this example, we should do so as a transaction so that we start and end with a valid product.
Data changes to the aggregate should follow ACID. That is, they should be atomic, consistent, isolated, and durable. It's also the responsibility of the aggregate root to maintain its invariance, such as the number and type of components it requires in the example. An invariant is a condition that should always be true for the system to be in a consistent state. When considering whether a particular object should be treated as an aggregate root, you should think about whether deleting it should cascade. In other words, if you need to also delete the other objects in its aggregate hierarchy. If so, it's likely the object in question should be considered an aggregate root.
Another way to think about whether it makes sense to have an object as an aggregate root is to ask, does it make sense to have just this object detached from its parent? In the example shown here, each component represents a specific piece of the product. Part of the definition for the component might be a standard part number, but it also includes specific product information like whether it's the left or the right hand of the figure. While it may make sense somewhere in the application to refer to a yellow hand part all on its own, referring to the left hand of a particular product that happens to use the yellow hand part is not likely to be referenced separately from the product object. Thus, we wouldn't provide persistence options for retrieving a single component separately from its product. We would retrieve and save whole products along with their components.
In the domain-driven design book, Eric Evans states this pretty simply. He says, an aggregate is a cluster of associated objects that we treat as a unit for the purpose of data changes.